Hello. Today we're going to be talking about the Continental tire supply chain. This is an interesting paper to me because I've actually done some consulting work for Continental Tires, as they have a plant here in South Carolina as well as other places in Germany and in the United States. This paper was in the IBM Journal of Research and Development, so you might find at the end of this presentation a little bit of a commercial aspect to it, trying to sell you on some IBM products. That's not my intent here. I just enjoy the paper for the different aspects it presents. So Continental Tires makes both OEM tires, or original equipment manufacturer tires, tires that go on cars like BMWs, Mercedes, Chevrolets, etc. And then they also sell replacement tires. We put Continental tires on my wife's car, for example. We're able to buy them at Walmart. So they're available through many different channels. And the idea is that this is a pretty big company. I mean, they do 10 billion euros a year in revenue, and they have 18 different production plants. And just making a tire is a pretty complex operation. The idea that there's 100 production stages per each tire, from the raw rubber to the formed wheel or the donut, it's kind of an interesting process. The fact that they have 40,000 employees worldwide with these 18 different production plants, you can start to get a feel for the type of complexity that they're dealing with. So they have different strategies where they make these tires. And we've talked about make to stock versus make to order. Make to stock makes sense for tires because they're not highly customizable once you get past the fact that, yes, there are a whole bunch of different sizes of tires, but they can make them and keep them in inventory. They don't degrade, and it's no problem to make a whole bunch of certain sizes and then figure out, as the demand signal is given to them, what they need to make more of. Now, tires evidently have some seasonal aspects to them, whether we have sales or promotions. Maybe people in the winter start putting on snow tires in certain areas of the world. So there are some seasonalities that they have to take into account in addition to this idea of their make-to-stock business. The idea of safety stock, of course, is that they have to make what they think are the right quantities to meet demand, but probably make a little bit more, because as they try to buffer against the variability in demand, the idea is that safety stock is the way to do that. You keep a little extra in inventory, albeit at a slightly higher cost, both in production and inventory carrying costs, in the hopes that your demand, if it is variable and it's on the high side, you can meet the customer's demand, rather than not having safety stock and having the demand be high and be unable to fulfill your customer's orders. The other interesting thing, like many companies, is they have many different production locations for the same product. So they can make a 275, 55R17 in 5 different plants, for example. And if you have that idea, you have different molds, different machines that are similar, some that are, completely different. So they have to figure out how and where to make which tires at which plants most cost effectively. Plus, they have to take into account the volume considerations. They have raw materials that could have long lead times, so we have to be cognizant of that, knowing that if I need the raw materials and they're 12 weeks out, I have to do the proper production planning to make sure that my raw materials are available to me at the time that I'm starting to do my production process. They use full truckload transportation. We've talked about this before, where full truckloads are the 53-foot trailers, maybe the JB Hunt or the Swift, whereas people talk about less than truckload, which are the 28-foot pup trailers. Sometimes you see them hauled 2 at a time. UPS hauls them. ABF hauls them. Actual true story, driving through Ohio, they actually have 3 trailers hooked together, which is a bit frightening to pass that vehicle just because of the way the trailers were starting to wiggle in the back. I don't know how heavily they were loaded, but the idea of 3 of those together is allowed in some states, but not in others for good reason. And the other part is that they have some custom-made manufacturing tools. And they might have a generic tool, but then they have it customized for their specific purposes. Maybe it's the raw material feeding aspects of it. Maybe it's the way the molds interchange with the tool, the way to make it more effective for setting up the tool. So there are a variety of different customizations that Continental does in the various plants. Now, they might have multiple copies of the same custom tool, but they also could have one-of-a-kind tools. And clearly, if one-of-a-kind tools are made for a specific kind of product, in this case a specific kind of tire, we'd have to know where those tools are located, because their location directly impacts what products I can make or can't make at that location. So when they think about marketing, they have to deal with their OEM, their replacement tires. I mean, they have to sell tires to everybody from Walmart to little mom and pop shop garages to small dealers of tires, discount tire. They also have a diverse product mix because they have some high volume products, maybe passenger tire cars for a Honda Accord, or a Ford Escort, or a F-150 truck, things that are very prevalent in the marketplace. But they also have some lower volume but higher margin products. I think about the tires I put on my wife's car, think about the tires that go on a Mercedes, Camaro, high-end cars, very wide, low-profile tires that there's not as much demand for them, but there's a lot of price in that tire. I mean, at least there's a lot of price for the customer to pay. I cannot comment on whether or not it costs them more money to make it. Clearly, they'd have more specific tooling to do so, but they have both high-volume, low-margin products and the opposite, the low-volume, high-margin products. We talked about the seasonality. And as they get emerging markets, as people start getting more and more cars, I've heard recently that BMW is expanding into China just incredibly rapidly. There's so much demand for the new wealthy class in China for BMWs and luxury items. Continental has to be ready to meet that demand in an emerging market such as China, or maybe it's in Indonesia or the Philippines. They have to be able to make sure they get there so that people don't just think Michelin or Goodyear. They recognize Continental as a key tire brand. So previously to this paper, to this effort, there was different planning strategies that were deployed at Continental. And I like this paper because it talks about levels of planning into what I would call strategic, tactical, and operational. What I call strategic, they call long-term planning. In their case, it was 1 to 3 years out. The idea of where we're going to make the products, how much capacity I need at each plant, and how transportation is going to move the products between plants. This is a higher level optimization type of study looking at strategic plans. When we look at what I would call tactical planning, what they define as midterm planning, that's on a shorter time horizon, maybe quarterly, maybe 12 to 18 months out. The idea here is that we're further taking our 1 to 3 year strategic plan and chopping it down into weekly production plans across the different facilities where we've allocated the demand in our previous step. And finally, what I would call the operational plan, which is more short-term scheduling and planning, more of the weekly or daily basis, is where we're actually figuring out, okay, I have the requirements to make this product mix of this different kinds of tires at this plant in this week. I'm then going to schedule how I'm going to do that on A shift, B shift, by the day, etc. So these different levels lend themselves often to different types of analysis tools. Many people would use optimization for the longer-term planning. They might use some optimization in midterm, but when you get down to short-term scheduling and planning, unless you have a lot of computational horsepower and a fairly simple processing environment or production environment, optimization might be too difficult. It might take you an hour to come up with a solution that you need every 5 minutes, for example. So we might use heuristics, we might use simulation, dispatching rules, lots of different approaches. Now, as I mentioned, this paper was in an IBM journal, and IBM acquired iLog, which is a company that makes a product called Cplex. Cplex was the gold standard for optimization. When IBM bought them, the thought was, I guess, we're going to have that as a service that we can sell to our customers. So the ability to have a whole bunch of computers running a whole bunch of optimization models in parallel could be a pretty powerful solution for real-world companies. So there are some challenges in this type of process. I mean, we're looking at a worldwide plan where we have billions of dollars or billions of revenue, billions of euros to come up with effective estimates for. Now, you could argue that the input parameters to this model, how accurate were they? Do we need to do sensitivity analysis? And we'll come back to that. But the key is when you're making these kind of plans, there's never one answer. There's a variety of answers depending on different scenarios that you wish to run. Some of their goals were to increase sales. Sounds good. We can do that potentially by making sure we can optimally figure out where we're going to produce products if we can match it to our demand signal. Because if I miss the demand signal, clearly I won't be able to get those customers back. I won't be able to fulfill those orders. People typically don't back order tires in my experience. They'll just switch to a different brand. But in addition to increasing sales, we want to do it in a cost-effective manner. So another goal was to reduce costs, because if I make the wrong products in the right place or make the right products in the wrong place, I might be able to meet demand, but my transportation costs could be rather exorbitant trying to move the products across the world rather than making it in a facility that's closer to where the demand signal is. And I also have these trade-offs, which clearly are the supply versus the demand. the more accurately that I can forecast demand, the more accurately I can forecast my raw material supply, my lead times, the better off I'll be. But these are often quite challenging tasks to accomplish. So some of the issues they were facing at Continental was a lack of distributed and collaborative planning. The idea of sort of silos or smokestacks. Everybody's doing their own plan in their own facility, worried about their own backyard, and not really looking across the enterprise or across the supply chain, trying to look for opportunities that the company as a whole could do globally better rather than just locally trying to optimize what I'm doing. We did see a lot of demand volatility, so a lot of uncertainty in terms of when the products are ordered in different locations and in different time periods. We definitely have a labor-intensive, which means time-consuming planning process. They did not have automated tools, tough to get the data. You know, one of Mason's rules is that the world runs on spreadsheets, and everybody has a spreadsheet to help them do their job. And if you have a very large spreadsheet, it can get very cumbersome. And if everybody has their own spreadsheet, doing their own planning in their own location, this can be quite a challenge to try to interface them together and talk to other groups about how they're doing, if they even ask the question. Data is always a challenge. You know, there's the data you want, the data you need, and the data you have. If we're doing this all locally, I might have a data source that might be pretty good at my plant, but another plant might not be the case. If I have bad data, the world's greatest forecasting model will turn garbage in into garbage out. So this can cause issues in forecasting when I have inconsistent data quality across the different lines of business. The other issue is that I have different tools in different places that can do different things. Trying to figure that out, matching that with supply and demand, is a challenge. Some of these tools might be portable and be able to be moved across different facilities if we decide to reconfigure or realign what we wish to make where. But some of the tools are very large and can't be moved, so you're kind of stuck with where they are and what we have to do. If we wish to expand to another location, perhaps I'd have to buy a separate tool. Perhaps I'd have to add extra capacity at multiple locations because of this one-off special kind of a tool that I've decided to use to make a specific kind of tire. And then tying back to the previous problems, let's hope that we hit the right demand so we know what we're making in terms of the right products. All of this together makes a very complicated problem, and trying to accurately even simulate it can be a very complex task, because the level of detail at which you model any system is key. You know, the best model, to me, is the simplest model I can build that answers the question I'm asking. If I need a detailed operational simulation model that's knowing about queue lengths and tool utilizations and staff scheduling and forklift movements, that's great for a given facility. I've built some of those models. But the data needed to drive them and the expertise knowing how to model the process can be quite significant. And if these processes or different production locations are different, it could be that I have to build a separate simulation model for each location, and that can end up being quite a daunting task. So some of the business constraints that they must factor into their modeling are limited resources. We have supply from a variety of locations around the globe. As I mentioned, multiple production locations that are making multiple products. We have the different production complexities in terms of one-of-a-kind tools, setups, batch processes. I have capacity issues. I know that I can't make as much as I want wherever I want. I have certain tool sets at certain locations that, depending on the product mix that I'm making, will result in a certain capacity, or how much I can make in terms of throughput, how much I can get out of the factory per hour or per day or per week. Different people use different planning models, different levels of abstraction. Some people doing strategic planning, some people doing tactical planning, some people doing it right, potentially some people doing it right in their mind, but wrong in somebody else's mind. Not to mention I have different shifts across different time zones with different kinds of employees, different kinds of unions. Many different things make this a realistic, nasty problem. So their idea was that they created this future allocation and capacity tracking planning solution. Now, my guess is IBM came in, offered their consulting services, their software, to help them build such a case, because while there's cost to do this, the benefits hopefully outweigh the costs. The idea is, first of all, let's create a standardized data repository. This is a key thing. I'm dealing with a semiconductor client right now who asked me to come in and build them a manufacturing requirements planning system, an MRP system, a dispatching system. And I said, okay, great, where's all the data? Well, we don't have that. So we had to take a step back and build a centralized data repository. The key is, if I have a centralized system that contains all of the data, I can use it as home base to feed ERP system, other data warehouses, other tools, other models. So a standardized data repository was an excellent first step that Continental made towards the right direction of getting this process figured out. We also have to figure out specific nomenclature or notation for products and resources so that we can visualize them across multiple sites, so a standardized naming convention was employed. We also, having this data, have the ability to look across time, so I have what I would call time phase data. And the idea that this system, this solution, has the ability to figure out at the strategic level what we're going to make where using this robust set of data and common terminology or common songbook in terms of what each part is really means, what it's defined as, so that there's no miscommunication across different plants and different sites. We have the capacity, availability of machines, different types of products, setup requirements, etc. All of the things necessary to do this appropriate level of planning. And if you look at this system, the thing I like about this figure, it's a little busy, but the left-hand side gives you the idea about the timeline and how it changes from strategic to what I call operational. And as we do that, we're doing design of the supply chain and new product introduction at more of the strategic level. And as we work down, we're into sales and operations planning, which then lets me figure out my inventory policies and how to balance my lines, where I put the orders, and then at the lowest level, how I actually schedule the tires in the plants, where they're going to be made, and also equally as important, how I schedule the maintenance of the tools to make sure that any unplanned downtime or tools failing is minimized. So this is sort of a nice picture to me from top to bottom of the different types of decisions you would make from a strategic to an operational sort of decision-making mode. And the idea is that this tool they built, this optimization tool, is up at the higher level. It's up at the level of strategic to tactical, as I mentioned, which makes a lot of sense. We're not going to do optimization in a production scheduling environment. It's just too complicated. The models would take too long to solve before I actually needed the answer. So this is sort of the scope of this fact tool that they built. The idea here, as I mentioned, they use Cplex Optimization Studio. So Cplex is a solver. You can think about it as a programming language, but it solves large-scale optimization models. The solver in Excel, if I haven't said it before, I'll say it again, is pretty much garbage. It can be used effectively for very small problems, but it can get wrong answers as you start to scale up. And most companies will use something like Cplex. The new program that I enjoy using is called Gurobi, which is G-U-R-O-B-I. It's actually created by one of the creators of Cplex who left the company, and I find it to be even better of a software tool than Cplex. Not to mention that Gurobi is a much smaller company, much more responsive. You can actually get quotes for single-seat licenses, whereas since IBM owns iLog now in Cplex, it can be quite challenging to get even a quote for how much it costs for me to get a license. When I work with my consulting clients and company, I almost exclusively get them to look at Gurobi for their software choice if they're going to need to buy an optimization solver. But this Cplex is a very powerful tool, so they use Cplex Optimization Studio for the mathematical model. We have this what-if capability, what they call a scenario repository, so that we can run different cases and store both the data that we ran and the outputs that we saw, so we can look at a suite of solutions rather than just a single solution. And also, people enjoy graphical user interfaces or GUIs. I myself do them for consulting clients because people like to click buttons. They don't want to see all the gory math. For me, they're a waste of time, but for users, they make the tool easier to use rather than knowing how to enter a certain command or a certain set of keystrokes. So the GUI actually made the tool more approachable, I would say, for people to actually use at Continental Tire. So this tool, as I mentioned, is at a high level, sort of the allocation level, which is what I'll call strategic, and capacity planning, which is at the tactical level. And it was able to figure out production quantities at locations, figuring out capacity, where the critical machines are, and what I can do at different sites. An interesting concept they call the bill of capacity, meaning if I have a given tool set, the capacity I have available depends on the product mix that I give to you. If I make a lot of a product that's really easy to make, my capacity would be higher than if I made more of a product that is difficult to make or takes more capacity. So capacity is product mix dependent, and being able to look at the mix that I'm assigning, the product mix that I'm assigning to each facility helps me get an accurate capacity statement. Once I know this, I can go down to the plant level and do more of a tactical approach, figuring out, okay, given the allocation of what's going to be made where, how I then drill down and have a separate optimization model for each plant, figuring out how to really fine-tune that plant's operations for the products that were allocated to it. So here it actually looks at the bill of materials, the raw materials, the tooling, the process steps, the setups to figure out at each plant what is the most effective way to get the tires made. So this tool does have its data repository. The data exchange is one of its strongest features in my opinion. And as a sales pitch, as I mentioned, this was sort of coming in the paper. It has a graphical user interface as well as what I just prefer, raw data, so I can do what I want with it. But the idea with this central repository across the globe, using the internet, is that we have the ability to log in with a VPN to this corporate database, and we can have the same conversation using the same data. We can have different levels of, I'd say, user authorization to look at different people have access to different parts of the data, depending on where they are in the organization, both geographically and hierarchically in terms of maybe their job title or their function. And these resources really help us figure out how and where I need to buy new tooling, where I should place it, should I repurpose it, should I change the mix given the existing tooling, because I'm trading off a whole bunch of costs. The cost to move something versus buy something new, all in regard to what products I'm going to make there and what kind of capacity that I need. And this idea comes up to the natural conclusion of cost versus benefits. If we're going to have this optimization model figuring all this out for us, it's great to minimize costs, but we also have to figure out what's the associated revenue I'm going to get from it, because if I can take my total revenue, subtract my total costs, of course I'm looking at maximizing my profit, which is the goal of any company, to make money. So the final slide here talks about what it is, the data quality absolutely helps. And the fact that they're all talking from the same sheet of music, the same, from central headquarters all the way down to a plant, they're using a standard tool to do the appropriate level of modeling. We know where bad data is, and if we fix it once, it's fixed for everybody because of the central repository system, especially more extracting the data out of these legacy systems to put them in the central data warehouse. There's a lot of data cleansing that has to happen as we start to feed and build that data warehouse, making sure we have the most accurate data going into it. And then we have this ability to run many different scenarios at different levels of granularity or extraction, such that we can make more effective uses of our capital in terms of investing into what products to make where, in what quantities, and when, which to me is good old-fashioned industrial engineering. We have this idea of figuring out where the tool bottlenecks are, where we might want to add tools, where we might want to shift production to different locations. And all of these were a nice outcome of this FACT tool that Continental Tires deployed sort of for their global production manufacturing operations. In the end, better decision making, cost savings, and improved customer service. Motherhood and apple pie, yes, but this is an excellent example, in my opinion, of industrial engineering tools and techniques being brought to bear on an important problem that can turn into real dollars for a company. This is my hope that as we work towards our final capstone class, we come up with projects that are rich in opportunity for us to apply our IE skill set to make things better, faster, cheaper, quicker, safer, and more profitable. That ends this lecture. Hope you have a great day.